This conference will now be recorded.
Cool. Hey guys, good morning. Guys, please participate because this is the concept is very important. If you deploy any application, these three services are a more top important for our day-to-day activities. Okay, don't be lazy, and if you guys are getting sleep, then after class finish, then you can sleep. Okay, but be available now. Fine. Now see this. Today we are going to discuss about the replica set and then service object. Two objects we are going to discuss in Kubernetes today. And yesterday we talked about the pod, right? What is the pod means? The pod is where we are running your application is running, as a container. Basically, as a terminology, it's a pod, but internally there is running a one container. That container we can run our application. That is what we do in the pod creation. But what happen if the pod will go down? How it will be create automatically? No, there is no option in the pod manifest. In the pod manifest, we don't have option in this here. We don't have option to that. We don't have a option to create that. The same way what we do, we are gonna using the replica set today. And two, if we mention that system array, I want a 5 containers. If one of the container will go down, like I mean one of the pod will go down, one of the pod will go down. No container here, only the pod. Okay, terminology. One of the pod will go down. Actually, it will be checked for your current state and desired state. Desired state means what? 5. In this case, desired state means what? 5. And current state means what? How many running? For in case you asked 5, and in a system there is a 4 running, what it will do? It will create one more container automatically. It will be match for your desired state. It will match for the desired state, and it will be running for us. Or else no, if you have 5 will be delete, 5 more will create automatically for us. 5 more will be created for us automatically. That is the where the role will play for the replica set. Means if you this is the main point. Okay, in Kubernetes, without this, the Kubernetes is nothing else. Now, how many you want, how many is running. Okay, in the same manifest file, there is a one more block will come extra. Only this block will come extra. That is the what it is. Let's say this one, specs part. Okay, that is we are calling this. Now this metadata anyway will be there inside the metadata and the spec. Inside the spec, this is a replica set, selector, and templates. And this may come extra for in this scenario. Clear? Clear, guys? Understand? Now this replica set, this is should be match. Hello world. This should be match, or else your application won't be up and running. Why this is matching? I'll let you know, like as next example, and we'll do some hands on how this communicating. What is the need of this? And when you go for service object, we must match for these labels with the service object match. Okay, we'll talk that today. Okay, remember this match labels and selector is a mandatory. Labels and selectors is a very important for us. We'll talk. Let's deploy the application. We'll see that. Now let's take a document. It is simple as that. Now, how many you want? You need to mention in the Kubernetes object. We are using a replica set. Means we are telling to the uh, Kubernetes master, whatever could be. Now I want to 5 containers at any time should be run. Now you tell to the system. System will be take that input. You are asking 5 containers, and it will be stored into a cluster store, and it will keep on checking. Now how many running? How many you asked? How many running? How many you asked? If it is if does not match that value, then it will be created automatically for us. It won't be increase anything. That is mandate. Okay, that is sure. Like as you're running 5, you ask 5, it won't create a 6 actually. Okay, that you can remember. Fine. The next what we do, let's Kubernetes practical document. Where it is. Lab practice in Kubernetes. This part we discussed yesterday and we debugged everything yesterday. Okay, and replica set. See, the parts are the basic building blocks in Kubernetes, but we deploy them directly and we get is a single fundable pod and we don't get any self-healing scalability. Okay, what we miss in pod? Self-healing and our scalability. We don't get this option. Self-healing and scalability. Self-healing means what? Now let's say anything goes down automatically creating. Scaling means what? Now today it's running a 3 containers and you want to 5 containers. That is a scaling. So if the pod fails, the game is over. Okay, nothing. It won't be created automatically. Because of this, we almost always create pods or via higher level objects like replica set and deployments. This brings all the goodness of self-healing and scalability and more often that not you are going to be deploy your application via deployment rather than the replica set. Why deployments is needed, we'll talk about later. Okay, that is maybe tomorrow. This is a replica set theory, how it will be pod wrap around the containers and bring to the bunch of benefits co-location, shared volumes, simple networking, secrets, and more. It's everything. If you are using the inside the replica set, all this will be shared, these all the things. Okay, co-location, shared volumes, and the simple networking, secrets, everything will be shared. Okay. Before getting into benefit, we need to think about the replica set. Basically, it is one-to-one relationship between the replica set and the particular pod. For example, let's say assume you have microservice application like comprising 3 services. You will more than likely build this. Each service is contained within the one pod. This will be give you 3 pods, one of each service. Okay, one of each service. To manage these 3 pods, you will be needed 3 replica set. That's because of single replica set cannot be managed more than one type of pod. Now, let's see here. Okay, this is for the one replica set and the multiple pods. Now I'll tell you what is mean. Okay, we'll do hands-on, then we'll get see. Now see here, it will come in this. This is the more extra. Okay, like this is the more extra, the replica set, and then what is meaning of replica set, and this is normally this template section, and this is previous one only containers and this spec section, right? The previously comes under here, but it will come now spec under spec we are getting this under spec we are getting the replica set one. Now this main all about the desired state and current state. Okay, and that is important for us. And read this basically the theoretically whatever we are done. Okay, let's see this. For example, let's say assume you have got an application, 2 services, front end and back end. You have configured things so that in the pod template, front end service and the separate pod template for the back end service to meet expectation demand. I always need a 5 instances. The front end pod running and the 2 instances back end pod running. Okay, let's see. This is the all theoretical about how many you want asking, how many is running. These examples, okay, theoretically. Now what we do, let's this is already there, right? Now what I do in this example, see the hands-on, then you will get more clear. I'm gonna deploy 4, as 4 is enough, okay? Don't deploy 10 or 20 like that. Just mention the 2 or 4, 3 or 4, okay? Just copy this. Guys, this is the clear now. This is syntax of the creating a replica set, guys, okay? That we can't change anything more. Clear, right? This is the common API server kind metadata spec. Inside the spec, how many replicas, how many selectors and template will come here in this replica set. And the normal specs is common, like container information about what is the container image imports and all. It's common. This is a replica set object. Okay, let's save this and let's apply how to deploy this, guys. This replica set. How do we are deploying? What is the command to deploy? Replica set, there is no replica set here. RS means replica set. Pod means that how many pods are running. Remember, see. What is the full command? kubectl, full you need to tell me. Apply fnf replica set.web. The replica set is created. Earlier we ran this replica set, but it's saying that sorry, yes. Amma. Now you, like as earlier is saying that no resources found, right? Now do that same. Now see, hello deploy. This is the replica set. How many you asked? How many running? How many ready? Clear na? How many asked? How many running? How many is ready? Total all are 4 should be matched here. Okay. Now go for get pods. See, there's a 4 pods are created. Same pods. These pods are different, but the name is same. When you do the replica set, this will come the extra. Like a same replica set. This is the some ID will be added for the replica set. Or because of uniqueness. Clear, guys? Understand? Now, in case you delete one pod, let's delete that. Okay, delete 2 pods. How many we asked, guys? How many we asked? 4, right? I'm deleting 2 now. See, currently how many ready? How many you asked? See, this is the one. Let's see, get pods again. This is 2 is terminating and 2 is created. If you can observe here, 2 is terminating and 2 more is created. Understand, na? Totally now it's 6. Now this is 2 are terminating and this again 2 more created. If you can see 13 seconds ago. 13 seconds ago. It was created in 101 seconds ago. Understand, na? Now if something will go down or if something got deleted, now it will be create automatically for us. It will be created for means at any cost our application will be make it for high availability and the self healing. And if you want a scalability, how you want to scale actually, let me go for duplicate scaling simple. Now if I'm gonna give here is the 6. Tell me now how many previously running? 4, right? Now I mentioned right now 6. Then totally how many parts are run? Is it 6 parts will run or 10 parts will run? Now I increase from 4 to 6 means previously 4 is already running. If I mention 6, the YAML file, and then if I run again, it will run in the 6 parts or 10 parts because previously 4 already started. Previously 4 already started. Now I added again 6 more. That means totally 10 or 6. Guys, sure, sure. Okay. See that replica set. That is a scaling. Okay, this is a scaling we are doing. Using deployment object, we do scaling with the command line. I'm sure that also in future. Now kubectl. Let's apply. See here. How many you asked? How many ready? Okay, now it's 4 is 6 ready. Means it won't recreate that 4 again. Okay, that is will be. It will check for that labels. Who are the labels are running? Okay, these labels are. This is the image and this is the labels selectors. Okay, now this will be a, let's say, hello world. If that all are having the same. Okay, let's see here. If you can observe here. One second. There is an option for F1 show labels. See, this is the show labels. Okay. Get pods. I think wide and both are not work. I think so. Okay. Is both comments not working? Earlier it's working. It's not working. Why? Default for show F1 labels. Why? Labels option is there, man. Why it's not working, man? Strange, man. This is really strange. I'm not sure why it's not working. Show F1 labels. Label should work here basically. By default, it's a true, false only. If you enable this, means that's a true. I'm not sure. Okay, leave it about that. See, that labels will show like this actually earlier, but I'm not sure this command is not working today. What is the difference, man? What I did? It's working now. Why? What is the difference? What is these two commands difference, man? Okay. Understand. BLES, right? Bells written. Okay. Show labels. Okay. Yes, correct. Okay, correct. Show labels. Yeah. Now see here the name, right? That is the if you someone will come up with this label that will treat it as a that guy only. Understand now? The label will be should be matched. It will be treated as a, okay, you are in my home only, my guy. Like let's say for same thing. You are coming with, I am starting one DevOps course. Okay, you are okay, like not only course or college, whatever. You are coming that ID card with your that specific team, like a specific batch. That means what? You are in that team only, right? The same way here also same. Now, if you're already running, if someone is coming with this label and to check this, if I try to again, create one more manually, what it won't do because it's already having this label with the 6 members, whatever you asked. Okay, clear na? Clear, guys? Understand? That is the what the replica set help us, okay, to create for you know how many pods you want, that many it will be run for us. Okay, we can do space or by slash, anything is same. Okay, anything is same. Okay, fine. The next, let's see here. There is multiple options here. Okay, here this is what we have done, right? What is the name we given actually? Hello deploy, right? Hello deploy. Okay. Get rs. Let's do that. Get rs. Okay, this is the what get rs, and hyphen o, right? Output is becoming less big. When it will show the container name, it will show the image name, it will show the selectors, everything will be show for us. Great, super. The next what we do, let's see some of things, set up this show labels. This is the one we had done. Expansion the current state. This is the one. Okay, if you want to print YAML file format or wide format, we can do WebRS. This is a different again. This is a different replica set. Anything is same, that's fine, leave it. Okay. Loose coupling replica set. Loose coupling replica set. Now here there is a this is also we are done, like as get rs and the part show labels. Now in the next step, okay, like I will see the delete the replica set and make the cascade equal to false. Cascade equal to false. Now basically what happens, right? Let me show that what is the problem here. Now if in case, if let's see guys, this is very important, remember, kubectl get pods. If I run this pods, what happen? This pod will be 6 pods will come. In case if someone deleted, if you want to delete this pod, let's say this replica sets, this pods is completely you want to delete, kubectl delete pod, and you delete 6 pods. What happen now? Is it delete or it will create one 6 more again? This completely I'm deleting. What happens? What happened, guys? What happened? See, 6 is deleting, 6 is creating. It won't delete. But replica set you want to delete. The replica set you want to delete. How we can delete? See, the pods are there. Pods are 6 is terminating, 6 is creating for us. And you want to delete the replica set, what we can use that kubectl get rs first. And then if you want to delete that, kubectl delete rs, that replica set you can delete. Okay, I deleted replica set. See the get pods. Then what happened now? The pods also will delete. Means parent will delete, childs, like as what are the pods we created through the replica set, everything will be deleted. Means if you want to delete the replica set, you can't. Okay, like if you delete the pod, you can't, nothing. The replica set will be create 6 more again. Okay, if you delete the replica set, pods also will delete automatically. Understand, guys? Clear now? And if you want to delete these pods, you can delete the replica set. If you delete the replica set, whatever that pods are creating, that child, everything will be like as that pods, that replica set, whatever the pods are created, that everything will be deleted. Okay, that you can remember. Very, very, very important. Okay. Now, next, in case, see here, replica set, I have created, this many pods, right? Like, let me change a small, anything, 5 or 4 or whatever could be. Let's keep it that 5 actually. Anything is fine. What I want to do, let me deploy this. My requirement is QCTL, but we won't get this kind of requirement in real time, but and we have an option. This I'm gonna teaching this, okay? But I never used in real time scenarios. See what happened, the 5 parts will create it for us. 5 parts will be creating for us, right? Correct. The 5 parts is creating for us. But in case you want to decouple with this, your replica set to this one. Decouple the replica set to these parts means even if you delete the replica set or cascading the replica set, the parts should be running. The parts should be up and running. That's how we can do. We have an option called as this is get parts, get rs, right? The 5 parts are running. Now what you do, you can do this, delete the, see, if you're deleting directly rs and then this replica set name directly, if I delete, the parts also will delete, right? Yes or no? Thus previously we execute this command, right? And in this scenario, you can use this option -FN cascade equal to false. Cascade, instead of false, we can use the cascade rfun. It's a deprecated one. Boolean value is deprecated one. We can use rfun. Means that replica set is called as a rfun, guys. Now means the parent died. See, the pods will be coming. The pod is running now. Understand now, guys? See, do the kubectl get rs? Do we have any rs? There is no replica sets, but my pods are running. My pods are running. In case there is a pods or replica set, so the replica set is running, you want to delete the replica set, but you want to pods want to running, only the pods should be running, the replica set delete. Even if you delete this, no, there is no more. If you see kubectl delete pod, if I delete one pod, what happened? What happened? See here, earlier how many pods are running? 5 pods, no? Now here only 4 parts will be running. It won't create one more automatically. This is terminating. Only 4 is running now this time. Means parent, there is no parent now. Parent is got died actually. Parent got died. The next what happened now? The child also, no one will be there to create one more. Create one more. Parents are died. Okay. Now let's say if you create again replica set, kubectl apply. What happened in this scenario, guys? In this scenario, what happened if I run this? What happened? It will create 4 plus 5, 9, or else it's a 5. I'm deploying replica set again. I'm deploying a replica set again. Means for my chairs again one more parent will coming now. Okay, like as an after die again this that parent is coming back. Now see this. Get pods. The container creating one more container is creating 2 seconds back, and get rs. It came back again. The 5 is running. How, man? This will how it 5. The labels are same. That labels are same. The same labels is already running, it treated as a that guy, that boy only. That, let's say, that daughter or that son. Understand? For this parent, if you have the same label, that guy is like a labels in the sense like a surname. So, okay, let's say, like if the surname that will be, or that is guys are your stuff. Like as that label, who are having that label, that you treated as that guy is your home guy. Understand? Na? Even the replica set also coming the same label. You are also have the same label. Then matched. Then matched. If both are names are common, then it is treated as okay. You are is my guy only. Then fine. I have already four guys are there. Then make a one more new guy. That's it. It's creating that guy. Clear now, guys? Even that means the replica set pods are loose coupling. The replica sets and pods are loose coupling. Even if you want to remove, you can remove the replica set without pods or deleting. Without pods or deleting. But we never use this real scenario. We have option cascade equal to R1. Cascade equal to R1 is the latest option. Clear, guys? Okay. And yeah, this is what we have done. And this is we are done. And this is we are done. This is we are done. Scaling replica set. Okay, this replica equal to 4 we need to scale. That also we have done. Okay. All scenarios we tested. Understand, guys, replica set? What is the use of replica set? Clear na? Everyone? Yes or no? Now tell me, you would apply the application. Now this, let's take a print. You create a one pod, and you can number of pods you can get using the replica set. Let's say this is the pod. This is the pod. Okay. This is the replica set. Replica set. If you say that replica set m number of the 3 replica set, it will create a 3 pods, right? Replica set 3 means that it will create a 3 pods, right? But it's running our application. It's running application inside the pod. But how we can access this map? How we can access this application? How we can access this application? We don't have option, okay? Because this pod IPs is not at all reliable. The pod IPs we don't have a reliable. Now you can't access with the pod IP. You can't access your application using the pod IP. See here, get pods iPhone worldwide. If you can see, you will get to know that which is the pod IP. This is the pod IP is not reliable, and that if it's a old pod will go down, it's a new pod will come. That pod IP is different again. Understand now what I mean? If your 5 pods are running, no, you can't access the 5 IP addresses, right? Yes or no? You can't access the 5 IPs and 5 browsers in your application, right? Is it possible? No, right? Even this will be one more pod will come. See what are the IPs are there. If a new pod will come, this IP will go down and then new IP will come. That means the pod IPs are pod will go on down and up and running, up and down like whatever it happened. But the IPs are will be changed. IPs will be changed. Okay, in this scenario, you want to access your application. Now what do we need to do? We need a object called as service object. What we want? Service object we want. Service object we want. Service object we want. What is that? Service object we want. That service object, what it will do? Let me show that. I think this also having a. Let's see, we have a document here also. Now see here, the Kubernetes service. Okay, let's see here what it do. We can do two inside and outside the cluster. Okay. Now you want to access the pods inside or outside. And if you want to pod in inside, there is the option called as by default is the service type. Service object type has the three types again. Okay, mainly one is the cluster IP. Cluster IP. Remember, it's a very important question. Cluster IP, node port, load balancer, and there is the external name, but these are out of box actually. External. Okay, this is for to communicate one namespace to another namespace, but mainly these three. But service object, how many types are there? Cluster IP, node port, load balancer. Cluster IP, node port, load balancer. This is the default one. When you create a service object, it is a default option. Cluster IP default option means you can't access outside of the your servers. Okay, if you want access internally, curl command will work. But you want access outside of the cloud, means that server means you want access through the browser. You don't have option. Then if you want to access that, you can use the either node port outside and this also outside. If you want to access outs application, either we can use the node port or load balancer. Again, node port having some drawback because if you want to access your application, each node IP, we are going to access that application, node IP and the node port, node IP and node port we are accessing. If your application is running on a five node IPs and node port we are using. Instead of that, these five nodes we can keep it into one load balancer. That load balancer URL we can use and we can access our application. The same like as the previously how we are running that, you guys remember in Docker we discussed, right? We set up nginx is a load balancer and two Linux servers we take, and then we running a two containers, one container in the one server, one container in another server. Now, instead of individually we can accessing, we can put the load balancer. We're accessing through the load balancer. Same concept in the load balancer also. The node port means individual server accessing. Load balancer means combining multiple servers and keep it in the one single URL for that. And here is the default, and this node port is IP range. It's also very important question. What is the IP like port range for this? This is the port range we can give 30,000 to 32,767 IPs ports actually. Okay, these are not IP, it's a port. Okay, any one of the range we can give inside our application. Okay, whatever the port you want it. If you're not mentioning anything, by randomly it will assigning one port for you in between this. Same, if you guys remember now, in a Docker, if you're not mentioning that, outside port, what happened? Docker will create one port. You remember? If you mention this, it will get automatically on random port. And if you mention this, 80 and this 8180, let's say. And if you mention this is your custom port. What the port you want to access a communication. If you're not mentioning this, what happened? It will randomly get like a 30,000 to 32,767, right? Same, that also same in Docker also. It will be use the same port range. Yes or no? Have you guys observed, right, in a Docker sessions? Okay, the same here also. Okay, if you want, you can mention that specific port, but in this case, we can give any port, but in this case, you must be specified in this kind of port range. Any one of the port range you need to give in this range only. You can't deal like as your 50,000, 70,000 like that. I think so. Now this is the range we are going to give that port range. Okay, let's see. Let's how we can declare this now. Let's see the theoretically service object. Here, see why we need a service object. Before diving in, we need to remind ourselves the pod IPs are unreliable. When the pod fails, they are replicated with the new pods with the new IPs. Scaling up the replica set introduce the new pods with the new previously known, unknown, and IP address. Scaling down the replica set remove the pods. This remove the network endpoints and the replica set application. All of them is pod IPs are unreliable. Okay, and we also need to know the three things about the Kubernetes service. First, we need to clear up the something terminology when we're talking about the service. Okay, let's see. Service REST objects in the Kubernetes API, just like as a pod replica as a deployment Kubernetes service. Okay, Kubernetes service is an object that API that can be defined in manifest and post into the API server. Its service object is kind of a manifest, and we are going to post into service object. And second is we need to know that the every service gets its own stable IP address, DNS name, and then port. And we need to know that the service uses labels dynamically associated with the pods. This is the very, very, very important. That means now, as per this diagram, this is the pods. Okay, this is the service. This is the service. This is the service object. This is the pods object. Now, how this pod will join into the service? Then this having the some IP address static is a this IP is never changed for service level, and we are accessing this IP to outside of the world, right? We're accessing this IP. This IP, this service object having giving one IP or node IP, a node wherever it's running, the node IP will take and will access this. Will access the application. How this pod will joining to the service? The because of that labels, both labels should be matched. Then only it will join into the service object. The labels will be matched if the service object also both are the same labels and both will be matched. Now let's say the label name, let's say for example, let's say app equal to web, let's say, and here also let's say environment equal to dev. There's the two labels are there, and service object to come up with the this app equal to web and environment equal to, let's say, dev. If these two like as two labels are matching, then this part will be go on joining to this service object. What do you meaning joining and all? I'll show you with the hands on. You will get more clear. Okay, wait for some time. And in case, for example, this service object come up with the two labels, and this guy come up with the only one label. One label. No, this object won't join into this service object, and this will be joined. Okay, if your labels are matching, it will be joined. In case you are come up with the like as more than labels. Okay, like as app is equal to web, and environment equal to dev. Okay, let's say reason for you know front end. Okay, like something, and then bu for, okay, let's say some guy, whatever maybe, blah blah, let's say bu some. You come up with the four labels for each pod, but your service object having the two pods, two labels. Now it will just check these two labels are available or not in this. If both are label are available, if even you have the multiple also, it's you don't need to worry about that. Even this also will be work perfect, means this object also will join into this service object. But how many labels are there? This must be matched into the pod. If you any one of the not matched, then it won't join into this service object. That means, as for this diagram, if you can see now, if we create a client, if you don't have access to this pod, okay, as of now, this question mark means we don't have a connection. To make it connection, what we are using this service object. This service object, this service object will be joining into this. All parts will join the service object, and we're accessing this application. See if the labels are loose coupling. See here what happened. If this service object come up with the zone equal to prod version equal to v1, let's say, and this zone is equal to prod version is equal to v1, zone equal to prod version is equal to, then these three parts will be joined into the service object. In case the service object come up with the two labels, and you don't have two labels here, only one label you have, that version 1 is not there here, it won't join in this service object. It won't join in the service object. In case you have the two labels, and if the two labels is available here, and it has a more labels also, that also will be joining into the your service object. Understand, guys? That labels are very, 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 very important for to joining these parts into your service object. Understand, guys? Understand, na? Okay, that is the reason the labels we are doing. And if you guys observe this label hello world having the same label for this whatever we deployed. If you can observe here, If you can see, what is the label name here? App equal to hello world. Yes or no? App equal to hello world. Now let's what I'm going to do. I'm going to creating service object. Let's see first of all kubectl get svc. Do you have any here? Any here? See here. This is the service object by default is the cluster IP. That's what you know. If you deploy anything, this is by default is the cluster IP. By default is the cluster IP. Okay, you can't access outside this. Okay. Now only this is the Kubernetes only running. This is the Kubernetes service only running here. Other than this, nothing is running. Now what I'm going to do, I'm going to creating one VI SVC, like any name that you are wish. Service.yaml file. It's same, but here there is no container information here. Just it's the labels and matching will be there. Other than is nothing. What I'm going to do, it's a commented one. It's a commented one. Just find one. This selector name, what it is there, guys? This is the hello world, and this node port. The application is running on this port, and accessing outside port is what? Like as 30,001 I given. Any like as in 30,000 to 32,767 we can give this. If you're not mentioning this, it by randomly one port will assigning you that. And this service type is which one? It is node port. By default, if you're not mentioning the service type under this port, what happen? By default is the cluster IP. By default is the cluster IP, but you can't access outside. If you want to access outside, you must have this node port type or either load balancer type. That any one of the type must be mandatory, and that port we can give. If you load balancer type, we don't need to give that node port. In that case, that is a different scenario. I'll explain that later. Okay, load balancer concept. That load balancer won't work in the QB basically, and because we need to install again third-party libraries, Meta LB or something we install, but that won't work in Kubernetes ADM. Then what to do? We can use the our any one of our cloud services like as what I mean application load balancer or anything that I'm gonna show you for with the EKCTL. Okay, at the end I'll show you. At the end I'll show you the load balancer type, the service object ingress, load balancer type, everything I'll show in the at once. Okay, right now we are going to discussing about the node port only. Cluster IP by default one. Okay, if you mention the service object, if you not mention this type, and that by default is the which type it is, cluster IP only, cluster IP only. Okay, this node port range we can give the, and you should be remember this is the labels for this metadata, but this selector is the right, the selector app. This should be matched with the name of your that replica set name, application pod, application labels. Is it clear now? The same name should be there. If it is a different name, it won't work. It won't work. Is it clear now? Okay, let's do one thing. I'll do later that. I'll change this and I'll do later. Is it clear, guys? Understand now? This service, this is nothing else. It's also same four objects: API version, kind, metadata, and spec. Okay, in the spec, what it contains, this type, and then which port is the application you want to running. This selectors will be there. The same selector, nothing. It's there is no container manifest here. Container manifest is available in the pod actually. Okay, and here just only labels and then ports and the no service type it will be there in the service object. And if you open this replica set, okay, and this name, that name should be matched. Clear now? Clear, guys? For this is a loose coupling for your container. This is a loose coupling for your container, and the replica set and these parts should be matched. This label and that label should be matched. If you're not matching, what happened? Your application won't be connect with the service object. Okay, this how many labels are coming now with this? Only one label at this point of time. Okay, one label, and that's the reason in the service object also we mentioned the only one label. Sorry, only one label. Is it clear now, guys? Clear, right? And the next what we do, let's deploy the service object. Apply F1F Now service object is created. Get SVC. If you guys observe here, this node port type, and this is the port we can access. See, this notepad created, and let's describe the service. Let's describe the service. Now this is the service endpoints assigning inside the cluster, outside the cluster. Just check this actually. Okay, this one. -o wide. Can mention this -o wide. These labels will come, and what you do, just describe this. Let's we can do this later. kubectl. Let's do the parts first. And see this IP address of this parts case. Okay, this is the 5 like as 10.3621 10.3801. Okay, and this is the IPs, and kubectl describe SVC. What is the service? This is service. Okay, if you can observe here, IPs. Let's see this IPs. 10.30.62 one IP, and that 10.36 echo 36.0.1, and then 10.38.0.0, and then plus two more. And if you want to see that only, and get get SVC. If you can see, observe here, get endpoints. Endpoints also not even it will also giving the same. Endpoints means it will show the like as what are the IPs are assigning for the specific only that port number, and then application. Like this is the service object is pointing out the service object. This is the five IPs. This is the 3 plus 2 more. And you want to more information about this, you can do -o JSON output. Okay, I think this is not giving that. This is not the service object is not giving that YAML file format. See, this is the IPs, and you want to see all IPs. This the 2 is hiding now. You want to get that. We have a command also that also. This will come like this only. Even this endpoints also will give like this. This one. We can describe this endpoint. Now we will get to know like as how many IPs is attached. This endpoint of this SVC, and we'll get to know like as how what are the IPs will attach this. What is the label? What is that namespace? What is the service name? All those. Clear, guys? Clear now? Understand? Means this IPs will be added in this. IPs will be added, like means this all IPs will be point out this service. Now let's access this service object. Okay, this service object we can access. Now kubectl get svc wide. Okay, now this is the one. This is the IP, this is the cluster IP and node port. Now what we can do, we can access for any node IP, any node we can take. Let's go for node. Shit. I'll show the UI for tomorrow. Okay, that is whatever we created. I'll show in a Kubernetes dashboard how look like after deploying applications. Sorry, I'm planning to terminate this. Okay, what is the port we allow? Okay, we need to allow that port also. Slaves, security group. What is the port, guys? 30,000. Okay, we already allowed now. We already allowed, right? We don't require now. All ports we are allowed. 30,000 to 1. See, this is the application we deployed over there. And take that, which sir, my question like as which node IP we need to take, either first node or second node. Okay, like which node we have to, like as 247.15, right? Which one I took? I think node 2, like 56. Let's select the 56. These ports are already allowed, guys, in system. Okay, we can see either any one of the node IP we can access because that application is not running in the single node, right? Now, if you can observe here, kubectl get pods -o wide if you do, and if you can see these pods are running either this node also, this node also. Three pods are running one node, two pods are running on another node. These are node IPs, our node IPs. We didn't mention anything deploy on this node only and deploy this node only, but the Kubernetes will be decided for that. And if you want to do that, there is an option called as node selector. Node select. This is also very important question they're gonna ask. There's a node selector. We are gonna choose that. Understand, guys? This is the endpoint what we are using. Just we'll get to know like as which service object, how many IPs are attached, what are the IPs are attached that are not. Okay, that is the endpoint will give the information for us. And this service object that labels should be matched. And you know those. And next class we'll discuss the deployment object and some dashboard stuff. Okay, and later we'll for couple of, this is the main four objects are very important. What is those? What are those? The pod, replica set, deployment, service object. Without these four, we can't deploy any application. Every application has these four options. Clear, guys? Clear now? But sir, we deployed, we access able to without deployment object, right? Today with this two deployment and like replica set and pod and then replica set. Okay, using this only we can able to access. But there is a drawback in replica set. What is the drawback? That we'll see that tomorrow. Understand, guys? Clear now? How Kubernetes man? Is it easy? Little bit difficult. The YAML files, don't think YAML files. Okay, that will syntax you will get for all the Kubernetes document itself. Everything in Kubernetes.io. If you go, no, nothing you want to do. Okay, everything, every is documented here. If you go for Kubernetes documentation, okay, for everything, okay, like as how we are using, what is the syntax we can use, what are the options we can use, everything will be available, all options. All API options are available. You don't need to worry about it all. Okay. Just understand mainly concept. You can't remember the syntax. Even I can't remember the syntax. Okay. Whenever we require, then we'll go for the service object, and we'll see that all the options and then all the syntax rules, and we'll go and we'll need to implement. Okay. Clear, guys? Yeah. Okay, guys. Then see you on a next class. Don't miss tomorrow class. Tomorrow class is the top most important class. The deployment object. The deployment object very very important. See, these guys are left. Eagle. Bye, guys.